Okay, this is 2.3 in your textbook, page 80. There's nothing new actually today. We're not discovering any new formulas. So it shouldn't be a very long lesson. What we are doing is applying what we already learned. Okay, so we already know about slope, we already know about midpoint, and we already know about our length formulas. Okay, so we're just applying them, and typically it'll be word problems. Someone want to read, give us an idea of what this is used for in real world, page 80. Okay, and nice and loud.
Ideally, the route of the power line should be as short as possible. A shorter route reduces the construction cost as well as energy loss due to the resistance of the wire. Engineers use analytical geometry to find the best route for the transmission lines that deliver electricity throughout the province. Analytic geometry is also a powerful tool for designing roads, buildings, pipelines, industrial machinery, and consumer products. This section shows how to apply analytical geometry and algebra to a variety of problems. Many of these problems involve several steps that require different skills. Developing a problem-solving process is particularly important for dealing with problems with such problems. These 4 steps can help you understand the problem, choose a strategy, carry out the strategy, reply.
Okay, good. So if you turn the page to the first example there, this is example 1 at the bottom of 82. I think it's a reasonable kind of blurb on why this math is used. And I like to read those blurbs sometimes at the beginning because it answers the question, when do we use this in real life? And this would be one scenario where they actually are using math. And the main formula here is the shortest distance between 2 points. Okay? And it's definitely used if we can create a grid system, which we do like a map, and then we give those points a coordinate, and then we can calculate the shortest distance between those 2 points. Important for a variety of things besides power lines, but that's one good example. Example 1, find the shortest route. I'll have Gianluca read. A ranger cabin, this is the bottom of 82.
A ranger cabin is to be built in a flat wooden area near the straight road that connects the 2 campgrounds in the park. A new side road will connect the cabin to the campground road. On the park map, the campgrounds have coordinates A 2.0, 8.5, and B 10.0, 4.5, while the site for the cabin is at R 6.0, 1.5. Each unit on the map grid represents 500 meters.
Good. Okay, and then read the question there.
Find the route that minimizes the cost of the number of trees that have to be cut down for the side road. Draw a diagram of this road.
Okay. So I'm just going to put the question down here. It's very important that we think about this problem before we start, because it's not straightforward what we're going to use, slope or distance between 2 points. We have to really figure out what it's asking for first before we start. Okay, so that's the drawing. We have 2 campgrounds and then a cabin site. So we want to figure out the best road. So find the route that minimizes the cost and the number of trees that have to be cut down for the side road. Draw a diagram of this route. So we have a road that's running between these 2 campgrounds. Think about it now. What do we want this road? We want to connect this road to this cabin site. Okay, that's what we want to do. This road needs to be connected to this cabin site. Not campground to cabin site, but the road to the cabin site. Okay, and we want to minimize that because all in here we have trees everywhere. Okay, so what would this road look like? How would you draw it? So some people know right away, but until you can figure that part out, you can't really start this question. So Connor, looking at this, how would you draw this? So I'm going to give you 3 options, okay, Connor? You tell me which one to use.
The one in the middle.
Why?
Because it's the shortest because it's direct.
Excellent, very good. So the reason why we would choose this line and no other line is because it's shorter than these two lines, right? Because we know the distance between any 2 points is a straight line, it's the shortest distance. So we want to go the shortest possible distance to this road. So now we only have to cut down these trees that are in the way of this road. Okay, obviously if we went this way or if we went this way, we know that these lines, there would be more trees that would have to suffer. So we're going to definitely choose this line. Okay, and I took the liberty there to draw in this 90-degree angle. Does everybody understand why that would be 90 degrees? Everybody get that, right, Matthew? Yeah, it's perpendicular. It's the shortest distance is going to come straight off this road. Okay, it's not going to have any angle at all. Okay, so now that we know that, what else do we know? Or what can we do? How can we find that? It says find the route that minimizes the cost and number of trees that have to be cut down. Draw a diagram of this route. Okay, so we kind of have the diagram. Let's see now, if we wanted to find the equation of this line, okay, because that'll tell us really the exact line itself. How would we figure that out? Michael?
You have to find the slope of the line AB, and then for line R, it would be the negative reciprocal.
Okay, and that would give us a slope, and then how would we get the equation of the line?
You'd have to find the point of intersection. So, or you have to graph and find the line intercept.
No? It's an easier way. So you're right, we would have to get, so we know that this is perpendicular, so we know if we can figure out this slope, then we can figure out this slope because it's the negative reciprocal, right? So let's call this point P. If we get the slope of AB, we know the slope of RP is the negative reciprocal of AB. Everyone agree with that? So now if I have the slope of this line, what else do I need to get the equation of the line? I just need one other thing. Santiago.
The y-intercept?
You're right, the y-intercept, but we don't have the y-intercept, so we can use something else in this particular case. Yeah.
You would plug in the coordinates?
Yeah, we just need a point, right? Because if we have a point and a slope, then we can find the y-intercept, right? And we just do that by plugging in. So let's go ahead and do that. We're going to find the slope, first of all, of AB. So slope AB. So we find our slope as negative 0.5. So if it's negative 0.5, that's also, we can write that in fraction form as negative 1/2. If we know the slope is a negative 1/2, this negative reciprocal, or the perpendicular slope, would be positive 2/1, positive 2. We want to do that, it's just 2. Okay, so now we have the slope of RP, and we have a point. So we're going to sub that point into our formula y equals mx plus b. Y is equal to 2x plus b. Sub in x and y. So y is 1.5. X is 6. 1.5 minus 12 equal to b. B is equal to 10.5. Sub that back into my original equation. I get y equal to 2x plus 10.5. Yeah?
Isn't it negative? Because 1.5 minus 12.
Oh, sorry. Yeah. Thank you. Good, so that becomes our formula for this line, or equation of that line. Any questions there? Okay, now the second part asks, find the length of the side road to the nearest 1/10 of a kilometer. Okay, so we want to find this length now. In order to do that, we do need this point P, right? Using our length of a formula line. So we need to figure out what the point P is. So in order to find out what point P is, we need to find out the point of intersection between AB and PR. Okay, so to do that, we need to set up two equations and use substitution in order to solve for it. So we need the formula for this, the equation of this line as well, AB. So let's go ahead and do that. So the formula for AB, we need to find out y is equal to mx plus b again. We figured out the slope, y is equal to negative a half x plus b. We sub in one of these points to figure out what b is. So let's sub in y, so 4.5, and x is 10. So we have negative 5. So 9.5 is equal to b. Now we sub that into our equation here. We end up with y equals negative 1/2 x plus 9.5. So now we have the equation of this line and the equation of this line. So the equation of AB, this is AB, and this is RP. Okay, now if we use substitution, we set those two lines equal, we'll find out the point of intersection between them. So because they're already set up nicely for substitution, typically I would use elimination, but in this case, the two y's are already set up, so we'll just sub in this y for this y. So we have an equation that then looks like this. I think I might be off the screen here, so I'm going to move over here. Here's our equation for AB. And this is our equation for RP. So we're going to use substitution now. So negative 1/2 x plus 9.5 is equal. Okay, now we can solve, solve for x. Negative 1/2 x minus 2x is equal to negative 1. X is 2/5. You sub that back into either equation, so let's sub it into this one.
Sir,
Yeah?
when you're doing the substitution, when you're just changing over the thing, the 9.5, wouldn't you take it away? Like take away 9.5?
Yeah, it'd be 20, negative
20, negative 20.
Sorry, positive 9.5. I made that mistake. I made it negative 1. Should have been negative. Yeah, you're right. Thank you. Negative 20. So this becomes negative 20. And this is negative 20. And this is 20 times 2 is negative 40 divided by negative 5. X is 8. Right?
Yeah.
Okay, thank you. Okay, once x is 8, I can sub that into this formula here. Y is equal to 2 times 8 minus 10.5. 18 minus 10.5. 16. Sorry. And 5.5. So our point of intersection then (8) and 5.5. So once I have that point, I now have 2 points on the line. I can figure out the distance. So I'll just move this over. So now we have point R, which is equal to 6 and 1.5, and point P, which is equal to 8 and 5.5. I want to use my distance formula to figure out RP. Okay, so we have the distance of them being 4.5 units away. It also says that each unit is the same distance as 500 meters. So you would then do total distance is equal to 4.5 times 500, which is going to be 2250 meters. So the side road is 2,250 meters long. Any questions there? Okay, so long process, but nothing was new. We used the same length of a formula here. We used slope here, negative reciprocal, for the perpendicular line, and then figured out our final answer there. No questions there? All right, let's look at example 2. It says the vertices are A, B, and C. Determine whether triangle ABC is a right triangle. So in this particular case then, you just need to check the slopes of each of the lines of the triangle, and if any of them are negative reciprocals, then you know it's a right angle triangle. Okay, so pretty straightforward. Not as complex as the last problem, definitely. So you're just checking those 3 slopes. So we have those points A, B, and C. We're going to check the slope of AB, the slope of BC, and the slope of AC. All right, slope for formula for a slope, y2 minus 1. So we can see here that then neither line is perpendicular with AB, or BC and AC, the slopes are negative reciprocals, 2 and positive 2 and negative 1/2. So these two lines are definitely perpendicular. So it is a right angle triangle. Okay, any questions there? No? And last one, example 3, median to a hypotenuse. It says show that the median from the right angle of the triangle in example 2 is half as long as the hypotenuse. Okay, so there's a nice drawing there on page 87 showing the 3 points, A, B, and C, and then it shows the median itself. So we want to know that the median is half as long as the hypotenuse. So the first thing we would do would be to check the length of the hypotenuse, which we can do easy enough with the length formula. And then the next thing we would do, so we can see the hypotenuse is AB, so we would check that length. And then the next thing we would do would be to find the midpoint between AB, so we'd use our midpoint formula. So that would give us D, and then we could check the length of DC and just confirm that they're a half. Okay, any questions there? I think it's pretty straightforward. It's a lot to write down. I'm going to leave it there though. That's on page 87. I think it's pretty straightforward, so I won't bother going through that on the board. But is there any other questions with this section? Ready to start the homework? Okay, let's start 2.3.